Actually, it is like rocket science. I know because we teach rocket science here. When we design rockets, we have to get it right the first time. We can't easily turn the rocket around and bring it back to the garage. We're applying the same design philosophy to vehicle architecture. You'd be amazed at the amount of similarities in designing any propulsion system, especially when it comes to dynamic modeling and simulation.
So we start out initially with an entirely simulated system, a simulated control system. And the idea of taking a hardware-in-the-loop approach is to, piece by piece, take part of the simulated controller functions and move them into actual hardware. So instead of being simulated, we'll have some functions simulated and some functions actually in hardware. To accomplish that, we'll take our supervisory control unit, plug it in, connect it in software to our HIL software, and then drive it with the same driving schedules that we've been running in the software-in-the-loop simulations. From that point, we can then inject errors, problems, and all sorts of things that we would normally not want to do to a real vehicle and do them safely with the simulated system.
Hardware-in-the-loop and simulation is an area that NI is continuing to invest heavily in, because not only is it a core strength for a company, but it's also helping engineers and scientists in aerospace, automotive, biomedical, many other industries develop their complex ideas into engineering reality much faster.
Using the sets of technology, software, and hardware that the students will learn during this competition, they are going to be in a very high demand area in a very tough automotive job environment. Everybody I know who knows these control tools has gotten a job very quickly.
So I haven't seen you around the robotics lab lately. What have you been up to?
I've been working on this new project. I joined EcoCAR.
Yeah? What's that all about?
It's actually pretty cool. I'm taking all the LabVIEW software stuff that I'm learning in engineering and I'm applying it to the car.
Oh wow, that sounds really interesting.
You're AE, right? Yeah, I'm AE. I actually just joined EcoCAR like 2 weeks ago, and
really?
I was surprised. I didn't realize how many parallels there were between like aerospace engineering and more mechanical engineering on a car, like the LabVIEW software you talked about. They use that in both planes and automobiles. Like there's so many similarities. So like I really think you should join, even though you're AE, because you'll get a lot of experience that you'll be able to apply both whether you're working on a car or plane or probably even a boat. I mean, it's pretty widely used throughout the industry.
That'd be great.
Yeah.
Yeah, the cool part is that LabVIEW stuff that you're using in the robotics lab, it's really cool because we're doing a lot of the same simulation type stuff on the car because we don't actually have the car yet. So we're doing a lot of like hardware in the loop systems. We're actually integrating some LabVIEW simulation with some of the actual like hardware that's going to be on the vehicle.
I quickly realized early on in the project that no one person can do everything. You need electrical people, mechanical people, and something they don't teach you in class is how to get everyone to work together as a team. 83 years ago, my school was founded with the mission to train professional pilots. We now offer world-leading programs in astronautics, that is rocket science, and aeronautics. Our EcoCAR team is looking forward to applying the concepts we've learned in this competition to building a greener, more sustainable vehicle.